Hello, sorry to keep you waiting. If you were waiting, okay. Okay, yes, okay, as well. Again, apologies for not starting on time. Actually, today, I just want to look at a few of the questions on assignment 5, just briefly, and that's it. Okay. And we'll just continue with the next topic in the course, which is cardinality. We'll just continue next Monday. Okay. Okay, so I want to look at assignment 5, if that's okay. I want to look at, I want to start with question 1. And it says we define the sum of two real numbers as the least upper bound, or soup, p plus q, such that p is less than or equal to a, q less than or equal to b, p and q are rationals. Okay. And then the question is to prove a plus b equals b plus a. And the solution is just to compare a plus b and b plus a. Well, it's just to say that for all p and q rationals, we have p plus q equals q plus p. Therefore, for all p less than or equal to a, q less than or equal to b, p plus q equals q plus p. And therefore, these two sets we have this equality of sets. And then what that tells us is that the least upper bound of this set if it exists, is the same as the least upper bound of this set. Okay, and the least upper bound of this set is a plus b. The least upper bound of this set is b plus a. So therefore, a plus b equals soup, p plus q such that p less than or equal to a, q less than or equal to b. And that equals the soup of the q plus p's. And that's the definition of b plus a, QED. Okay, so this was just an example of how you can use the least upper bound property to prove things about addition of real numbers. Okay. Okay. And then I also wanted to talk a little bit about question 2. So that says, again, you define A times B for A greater than 0, B greater than 0. AB is just the soup or the least upper bound of PQ, where P is less than or equal to A, oops, and Q is less than or equal to B. And we have to show that AX is less than B. Oh, AX is less than BX. As long as A is less than B. Okay. Okay. So we need to come up with a strategy. We need to prove one's least upper bound is less than another least upper bound. Okay, so one strategy for that is to show to show that any upper bound for BX is an upper bound for AX. Okay, so we can show that if let's see. Yeah, that's one option. So we could say like let P be less than A, and Q be less than X. Then P is also less than B, since A is less than B. Okay. In other words, this set that defines A times X is a subset of the kind of things that define B times X. So what you can say is that PQs it's contained in all the PQs like this. Okay. So therefore that the soup of this set is less than or equal to the soup of this set. So this tells you that AX is less than or equal to BX. And now you want to get a strict less than. Well, how do you do that?
Excuse me, sorry to interrupt.
Yeah.
But there's someone said they were in the waiting room.
Oh, there's someone in the waiting room. Oh, yeah. Sorry about that. Okay, well, I'll apologize to the person. Thank you for letting me know. Okay, sorry for keeping you in the waiting room. Okay. Okay, so we can see that we can establish AX is less than or equal to BX. And now we just want like a strict less than. Okay, so right? So, but what we can do is, since A is less than B, we know from class that there's a rational number in between A and B. So there exists, let's say P, a rational number such that A is less than P is less than B. This is from class. Okay. Okay, and what this tells us is that what this tells us is that you know, okay, like what we can do is use this P to like make sure that AX is strictly less than BX. Okay, because we want to find Q such that PQ is less than or equal to B, but PQ is greater than, or sorry, PQ less than or equal to BX, but PQ is greater than AX. So how would we do that? I'm not sure how to do that. I think what I have to do is think about it some more and then post a video about it. So that is probably what I will do. Of course, you don't have to wait for me to do that. You can also try this question out for yourself. You know, for now, I'll just put like a question mark. I don't know. Okay. Oh. But yeah, so I guess the point for this assignment is just, I wanted to give you just the general idea that once you prove the least upper bound property for the real numbers, you just define everything using least upper bound property, or define as much as possible. So you define addition and multiplication using the least upper bound property. Then you just go from there. I guess another strategy for the question 2. Another strategy for question 2, which might help, is show AQ is less than BQ for all rational Q. And then use that. Then use that property to show that AX is less than BX. So that's one option. Okay, so this is a strategy. So first show that AQ less than BQ for all rational Q, and then use that to show that AX is less than BX for all Q greater than 0, and A and B positive. And the reason you can do that is because AX is just going to be the soup of AQ, such that such that Q is at most X. And BX is going to be this soup. Okay. And then what you can do is you can show that everything here is less than everything here. And then you can show, you can also use the fact that there's some rational P that's between A and B to see that then you can show, like, you can use that. Okay, so you can try and combine everything. But also I'll just try and flesh out like a more concrete strategy in a video later, if that's okay. Okay, I guess I'm just gonna stop here. Unless you guys have any questions. So the coursework, that's gonna be, just briefly, that's gonna be next Tuesday. It's gonna be on the first 3 assignments. Meaning, whatever the, like, so basically, like, to start with, we had all the axioms, the basic axioms. And then after that, we had relations. And then after that was the start of the natural numbers, all of those things. So like basically everything up to induction. Okay. So, try and review the assignment questions. Even the ones that weren't assigned, try and do those. If you have a chance, you should be okay. Okay, I guess that's it for today. Yes, in general, you can email me with questions, and also you can email me with questions during the exam. But just let me remind you, just due to whatever regulations, you cannot do that during the final exam. But coursework exam, go ahead, email me whatever questions. Yeah. Just so you're not surprised when the final exam comes. And nothing really I can do about that. Okay. Okay, so yep, I guess that's it. Sorry for the late start. Probably if you're watching this on YouTube, you might have tried to sign in and I wasn't there. So sorry about that too, for any people in the future watching. Okay, yep, take care everyone. Okay, bye.